So good evening once again. Matinee free webinarലേക്ക് എല്ലാവർക്കും സ്വാഗതം. അതുപോലെ ഇന്ന് ഒരു എക്കോണമി ബേസ്ഡ് ആയിട്ടുള്ള ഒരു ടോപ്പിക്കാണ്. ഇതിനു മുമ്പും ഹൈഡ്രജൻ ഫ്യൂവലിനെ കുറിച്ച് സാറിൻ്റെ ക്ലാസ് ഉണ്ടായിരുന്നു. സാറിൻ്റെ 34ാമത്തെ ക്ലാസ്സാണ് ഇന്നെടുക്കുന്നത്. ഇന്ത്യൻ നേവൽ ഫോഴ്സിൻ്റെ ഭാഗമായതിനു ശേഷം ഇതുപോലെ വളരെ പോസിറ്റീവായിട്ടുള്ള ടെക്നോളജി അതുപോലെ എക്കോണമി ബേസ്ഡ് ആയിട്ടുള്ള ക്ലാസ്സുകളൊക്കെ സാർ കണ്ടിന്യൂസ് ആയിട്ട് എടുക്കുന്നു. ഇന്ന് ഹൈഡ്രജൻ എക്കോണമിയെ കുറിച്ച് പറയുമ്പോൾ നാഷണൽ ഗ്രീൻ ഹൈഡ്രജൻ മിഷൻ അല്ലെങ്കിൽ ഗ്രീൻ ഹൈഡ്രജൻ പോളിസിയുടെ ഭാഗമായിട്ട് 2030 5 മില്യൺ മെട്രിക് ടൺ ആനുവൽ പ്രൊഡക്ഷനാണ് നമ്മൾ എക്സ്പെക്ട് ചെയ്യുന്നതെന്ന് ഇതിനു മുമ്പത്തെ ക്ലാസ്സിൽ നമ്മൾ കേട്ടിരുന്നു. പക്ഷെ എന്തോ അതിന് റോഡ് ബ്ലോക്സ് ഒക്കെ ഉണ്ട് എന്ന് തീർച്ചയായിട്ടും മനസ്സിലാക്കേണ്ടതുണ്ട്. സോ ഇന്നത്തെ ക്ലാസ്സിൽ തീർച്ചയായിട്ടും അതിനെക്കുറിച്ചൊക്കെ സാർ കൂടുതൽ എക്സ്പ്ലെയിൻ ചെയ്യും. നിങ്ങളെല്ലാവരെയും സ്വാഗതം ചെയ്യുന്നു. അതോടൊപ്പം കണ്ണൻ സാറിനെയും. കണ്ണൻ സാർ, യുവർ വർക്ക്.
Thank you, Sabu. Thank you very much. First of all, thanks to you for giving me another opportunity to discuss an emerging techno-economic issue. Today, it's about energy transition. The whole world is pursuing this as a part of their fight against climate action. Because of changes in climate coming, they are programmed to fight against that disastrous effects of climate action. And one of them is regarding hydrogen mission. For nearly 150 to 200 years, we have been living in the comfort of energy extracted from fossil fuel, be it coal, petrol, diesel, etc., etc. We have been living in the comfort of those energy given by fossil fuel. We are overutilized it, caused global warming, which has led to climate changes, disastrous climate changes around the globe. We are all witnessing it in different parts of India as well. Scientists have identified that we can substitute fossil fuel by hydrogen. Hydrogen was earlier used in as a rocket fuel, but they said, no, now you can utilize hydrogen as a substitute for fossil fuel. Now, this transition from fossil fuel to hydrogen will have to be managed at the global level so that overall every country is able to absorb these changes in technology and implement the necessary infrastructure. Similarly, in India also, we have to do a national program, which has already been, in fact, completely planned and started in 2023. It's more than 2 years since we started it. But there are some challenges which are appearing now for India to implement the program of green hydrogen and the targets which they have set for 2030. I have made a presentation for you on this. I'll upload the same and then we'll start the discussion. Right. So the roadblocks to India's hydrogen economy is what we are going to discuss today. I will go very slowly. It is slightly technically intensive, so therefore I will go slowly. The first thing is there's a linkage between fossil fuel and global warming, which all of us know, and we are suffering to a great extent because of the global warming, the changes in climate, excessive monsoon, disturbance to monsoon patterns, etc. Scientists said, as I told earlier, let's get hydrogen to replace fossil fuel. hydrogen is not an unfamiliar element to us. It's already being used in steel production, crude oil refining, fertilizer production. All these require hydrogen so that industries know how to deal with hydrogen. But there is no hydrogen in the atmosphere. So with no hydrogen in the atmosphere, where are we getting this hydrogen from? It is required for steel, refineries, fertilizer. We have to generate that hydrogen. And if you generate it with using renewable energy, very good. Otherwise also you can generate. But the fact is we require hydrogen. It is not in the atmosphere. And therefore today also we are generating hydrogen to run the industries like steel, refineries, cement, fertilizer, etc., which are also important for infrastructure. And even for every economy in the world, refineries have to provide the necessary fuel. So if green hydrogen is generated, that means you use renewable energy to generate hydrogen, then you get it almost free. I'm saying almost free. Sun's energy, you get free. You have to spend some money on solar panels, generated energy, and generate electrical energy, and use that for getting green hydrogen through some electrochemical process. Then you have the substitute hydrogen available to you to replace fossil fuel without very much of expenditure. And that is the emergence of a new economy. A new economy evolves when you take hydrogen by some process from nature, using sun's energy, and then use it for industries. Obviously, it should give you some benefit. We'll discuss that. And how does this economy work? What is India's plan? Where are we now? What is it holding it up? That's what we're going to discuss in the next half an hour. Many countries have launched programs. India has also launched in 23, as I told you. So let us see hydrogen very briefly, because that's very important to understand. Hydrogen H2, which is what I'll be referring, it's colorless, odorless, and very light. Can you believe that 1 gram of hydrogen occupies 11 liters of volume? It is so light and so much of volume it occupies. 1 gram is equal to 11 liters. So it is a gas which occupies a lot of space. If you compress it and cool it, the volume comes down. But the normal conditions of temperature and pressure, it occupies a lot of volume. This is the nature of hydrogen, which poses some problems as you go along, we'll discuss. It doesn't get dissolved, highly inflammable, and it's got high energy content. It can deliver energy to another place where it combines with oxygen. We'll discuss that as we go along. It is required for many engineering applications. I already told you about steel, fertilizer, etc. Atmosphere presence is very, very small. I've given the figure there. So it is actually not existing in atmosphere, but abundantly available in the universe. Water is H2O. So hydrogen is available in water. Hydrogen is available in fossil fuel also, be it coal, be it petrol, diesel. They're all compounds of hydrogen. So hydrogen is available, but you have to take it out of water. You have to take it out of these chemicals. Voluminous gas, I told you. So transporting hydrogen, one has to be very careful. It is risky. So normally they transport it as a compound. And there later you can take out hydrogen from it, like ammonia. NH3 is ammonia. That is one way of transporting it when you want to transport large volumes of hydrogen. So we have to generate hydrogen to get fuel, the new fuel. And then you have to store it, we have to transport it and give it to hydrogen bunkers, like petrol bunkers, and then they should be able to distribute. So there are a lot of new technologies involved. how is India coping up with all this in the hydrogen economy program. So environment has got water and air. If you give water, which is H2O, you can generate hydrogen, transport it, utilize it in some industry, steel, cement, etc. And there again, it will come back to water because it takes oxygen from air and water comes back to environment. So this is a sort of a hydrogen sort of a cycle which is abundant in nature. So much of hydrogen is available. We have to only spend time. We have to find methods of generating it mostly from water. So who all require hydrogen now? Let us see. First is steel. Iron ore is given to furnace, then you get pig iron and steel. I'm not going to discuss those issues. But hydrogen is required in the furnace so that the oxygen in iron ore is taken away by hydrogen to form water. It will become steam and go out. And the iron is separated from iron ore, which is converted into purified etc. to form steel. But iron ore also has got, how do you get the heat? You have to heat the furnace and pass hydrogen to get this. And heating is done by coal. And coal and oxygen react to form carbon dioxide, which is what you're worried about because of CO2. So India has got about 50 steel plants producing 150 million tons a year. All of them use hydrogen generated from a coal-based process. That means coal is heated up, steam is passed over it, steam is splitting into oxygen and hydrogen. Hydrogen is available separately for the steel manufacture, and coal carbon forms carbon dioxide and pollutes the atmosphere. If you can give this hydrogen by some other method other than burning coal, then we may be able to reduce the carbon dioxide emission, which is causing global warming. Just to give a detail, 50 kgs of hydrogen is required for 1 ton of steel to be made. So large volume of hydrogen is required. Through this, you have to feed it from somewhere. How to feed it, we will see. I will just take refinery. Refinery also requires hydrogen for desulfurization of the fuel, petrol. So this hydrogen is also produced by a coal process, and they pollute the atmosphere, and you get petrol, diesel, naphtha, etc. But it requires 35 kg hydrogen for 1 ton of crude to be refined. There are 23 refineries in India. Details are available on the slide. Chemical industry, ammonia to be made. Again, hydrogen is required. How is hydrogen bought? Hydrogen is made from coal being heated up and steam passed, and hydrogen comes. And CO2 gets emitted from the factory, polluting the atmosphere. So I give you 3 examples. Steel, fertilizer, and a chemical plant producing ammonia. All of them require hydrogen, and they get it by burning coal and passing steam over it. Steam is H2O. So it splits. H2 separately is collected, oxygen combines with carbon, this is carbon dioxide. Now, this is a big issue. You continue like this, then your global warming cannot reduce, because one of the important aspects in global warming is burning of coal. That you should reduce. I'm talking only about industries where coal is burned for producing hydrogen. Suppose you can connect a pipe here, hydrogen coming from somewhere else, then the coal need not be burned. In all those 3 factories, you remove the coal and put a pipe which will give you hydrogen. Big pipe which will carry lots of hydrogen to the ammonia plant. So let us see how is hydrogen produced in fertilizer and fertilizer plants. As I told you earlier, there are 2 ways. One is coal is burned in a furnace with steam. As gas comes out, carbon monoxide and hydrogen, that is separated. Hydrogen comes out separately. Carbon dioxide comes out as a black cloud to the atmosphere. If you burn coal, this is your output, hydrogen and carbon dioxide. Another method is you burn natural gas. Natural gas is a little expensive for India because we don't have too much of natural gas reserves. So coal is cheaper for us. So mostly we use coal. But many of the ammonia plants and etc., they use natural gas. Natural gas is, cement also uses natural gas. Natural gas is burned, same technique, same method. CO2 comes and hydrogen comes out. Here CO2 is less. You can see the black cloud is slightly smaller. There's a difference between these two. When you burn coal, this hydrogen is called brown hydrogen. That's a name given. If you say brown hydrogen, that means you're burning coal. And it is given to steel, refinery, fertilizer plants. So I told you when pipe comes there, it actually comes from here. This is a part of the factory which is elsewhere, and from there the hydrogen comes. Suppose you burn natural gas, it's called gray hydrogen. And that is mostly used in fertilizer plants. So this is how it is being done today. But both gray and brown emit carbon dioxide. Brown emits more, gray emits less. But they are causing global warming. So India's total emission of carbon, if you look at, 25% is by industries, all industries put together. 45% is by power generation, thermal power plant, which is producing electricity for you. They burn coal, they produce steam, steam turbine produce electricity, and you get electricity in your house. Industries get, hospitals get everywhere. Supply is given by power generation. So 45% comes from power generation, 25 is industries, transports, trucks, buses, which run on diesel, produce a lot of smoke, cars, which run on petrol as well as diesel, they produce less smoke because smaller engine, and that is about 15%. Otherwise, there are some other emissions which are about 15%. So India's carbon emission is 4,100 million tons every year. And it is not reducing, it is only increasing. And we are causing more global warming. So it's a serious issue for us that we have to reduce the size of this black cloud. Some method. Now, go back to industries. If you can give the industries hydrogen through some other pipe coming into the factory, then they don't have to burn coal. The carbon emission reduces. It will reduce by 10 million tons every year if you use 1 million ton of hydrogen. So you require lots of hydrogen to be produced by some method. What is that method? We will see. So the method used in carbon hydrogen is by electrolysis. All of you have learned in school. If you split water, you will get 2 times the type of hydrogen and oxygen using battery supply. Now you have to produce lots of hydrogen, so you have to go for electrolysis plant. And the plant will be something like this. This is the first plant made in India, in Hasira, in Gujarat, by Larsen and Toubro. They have designed and made this. You can see how big is that electrolysis plant. It works on 1 megawatt of power, and it produces in 3 hours whatever is the hydrogen required for 1 ton of steel. And India is producing 150 million tons of steel. So you can imagine how much of green is required, how much of electrolysis plants are required, how many numbers are required at different places to produce hydrogen without burning coal. Obviously, a lot of money is required to make all these electrolysis plants. They may work on solar, but these electrolysis plants have to be made by us to make sure you don't burn coal. Now, if you get hydrogen from an electrolysis plant, which is running on solar power, it's called green. Earlier, I told you brown is for coal and gray is for natural gas. Now, green is for solar energy. And if you want to make 1 million ton of green hydrogen, 1 million ton, if you want to make 1,000 plants like this are required. 1,000 plants are required. And you have to put these plants very close to steel, cement, fertilizer, refinery, because the hydrogen pipe has to go inside. You can't run it over kilometers and kilometers. So you have to co-locate these electrolysis plants, hundreds of them next to each refinery, or produce a very big one, which has got the capacity of 100 such electrolysis plant. This is the first one which has been made for 1 megawatt. So government has formed a national mission to make electrolysis plants in plenty, design them, build them, and get them fitted in various industries which are burning coal. So that is the first step. So what are the challenges? The first challenge is, I've got 5 challenges. The first challenge is thousands of electrolysis plants that we made in the country. They had to be fabricated, they had to be constructed, and they had to be fitted and customized to the industry which is going to use it, depending upon how they want, what pressure of hydrogen they want, what flow of hydrogen they want. So they had to customize. Second, they have to be fitted inside the industry plant, inside the factory premises, so that you don't run long distance of pipes or you don't have to send by trucks. And they have to work on renewable energy, so you have to require a solar farm somewhere in the nearby area, or you have to get it from a green grid, so that you're not using energy run by a thermal power plant which is burning coal. Then it is not worth it. You have to use solar energy only, or you have to use wind energy only. You have to use renewable energy. In India, for information, nuclear is also called renewable. Hydro is also called renewable. So we will generally say renewable energy is required. And most important, the industrial plant which is presently burning coal has to be modified to take hydrogen from somewhere else. So the coal side has to be closed down, this has to be opened, and hydrogen pipe has to come in. So some changes are required in that factory. And you have to keep the cost of this green hydrogen as low as possible. Otherwise, your green hydrogen mission will not be cost effective. It's an economy which has to run. So you have to minimize it by making sure green hydrogen is used elsewhere also. So what is the thrust by this mission? Produce lots of green hydrogen, lots and lots of green hydrogen, give it to the industries wherever they are using coal or natural gas, and give it to for also cars to run, or give to trucks to run on green hydrogen, or run for power generation by mixing it with natural gas, or give it for cooking in your house by mixing it with again natural gas. So these are the various ways by which you can use the green hydrogen which you produce from solar energy. Why do you want to produce so much of green hydrogen? Unless you go on a very high scale of producing green hydrogen, the cost per kilo of hydrogen will not come down. And that is important for this economy. So at this point, I want to say there are challenges, but the most important challenge is making a lots of electrolysis plant and getting them fitted near the industries, modifying the industrial plant to take hydrogen from another source and non-burning coal. So a national mission has been launched 2 years back. It has got 2 objectives, one for 2030 and one for 2050. I'll quickly run through 2030. First is, as I told you, make lots of electrolysis plant. I'll call them EP. Second is, give to those industries which are burning lots of coal, and they are called by a name hard to abate. That will be very difficult to make sure these industrial processes can be changed that easily. They're very difficult, but we have to go through it to stop coal burning and go for green hydrogen. Third, we want to produce 5 million tons by 2030. That's what the government says. Where we will reach in 2030, I'll tell you later. But the government says we want to reach 5 million tons by 2030. Then give green hydrogen. I told you, produce 5 million tons is lots of green hydrogen. So give green hydrogen to thermal power plants which are burning coal, don't take coal. There you use natural gas and blend it with green hydrogen. Give green hydrogen for trucks, cars, and even for gas supply to your house, piped gas supply to your house. So this is what is being planned, and they want to reduce the emission of carbon dioxide from industry, transports, and even domestic sectors. By 2050, the goals are even bigger. The mission says we'll produce 28 million tons. That's what the aim is, almost 90% with green hydrogen. You can also have normal electricity being used for hydrogen. Then it is not green. It will be called by some other name. But 90% they want green hydrogen. They want to export green hydrogen to Japan, Korea, and European Union because they don't have so much of solar energy like India has. They are up in latitude. They don't get sun energy, solar energy as much as India gets. So India has got an advantage. Lots of solar energy in India. Utilize them to produce as much green hydrogen as possible, which is the fuel for tomorrow. Like Middle East to give lots of oil for the last 100 odd years it has been giving. Now onwards, whoever gives a lot of green hydrogen will be having the position of power because that is the new fuel. But it has to be green. It has to be based on solar energy. And countries close to equator will have the capability, the resource to produce green hydrogen. India, if we do this, we'll reduce import of oil from Middle East. It'll come down because petrol and diesel will be going out slowly. I'm talking of 2050. We'll be going out. So we don't have to import. We don't have to import ammonia, which we're importing a large quantity now. And we're also importing some coal because Indian coal is very, very ashy. Lots of ash content. And therefore it produces very thick black smoke as compared to imported coal. So we have been using some imported coal also. And it is expected that we'll reduce the emission by 60% from what is there in 2023. It's a huge contribution by India towards global warming to be overcome. We will get the global warming reduced from India's point of view by reducing our CO2 emission by almost 60% of what we are doing in 2023 by 2050. And we'll be able to bring out this hydrogen economy and have it run parallel to our economical growth. At the same time, decarbonization is taking place. So you've got decarbonization taking place, economy is growing, and a new fuel running in called hydrogen, produced from solar energy, therefore green hydrogen. And that is the hydrogen economy which is going to take place in the next 25 years, which is going to happen world over, is going to happen in India in a big way because we've got lots of solar energy and we have the inherent capability to produce a lot of green hydrogen. So I will talk what is the present status of phase one. Phase one is 2030, you may remember. The present status, we have started making a lots of EPs, electrolysis plants. It has been set up in Hazira, I told you, by Larsen Tubro, then in Bikaner by a company ACME, NTPC has got, GAIL has got in Vijaypur, BPCL, HPCL, NTPC, all have small electrolysis plants. Why small? Because it's a technology initiative. It is being inducted. They want to get familiar with technology of the electrolysis plants and how it will produce the desired hydrogen pressure for that particular industry. So moment they are comfortable with it, then they will expand and produce as much hydrogen is required to reduce the coal burning. I'm not saying coal burning will become zero, but they will significantly reduce the coal burning. Today, we are only producing 38 megawatt of green hydrogen through electrolysis plants, which produces 8 tons a day. That's about 2,500 tons a year. But we want to produce 5 million tons. Big way, long way away. We have to do huge upscaling of electrolysis plants and integration with industry by 2030. Will it happen or not happen? We'll discuss. What government has done, they have shortlisted 8 firms for producing EPs, electrolysis plants. And PLI scheme is being implemented so that their production goes fast. So far, it has not started. The firms have been identified, but the contract has not been signed. So another 1 more year. So it will be 2026 by the time it starts. So 2030 target is doubtful. 5 million ton of production of green hydrogen is almost ruled out. I don't think we will reach there, but it will be something lower than 5 million ton. I've done some calculation, I will tell you. Meanwhile, India and Egypt have signed a joint venture to set up near Suez Canal to produce 20,000 tons of green hydrogen, so that many operations which are required in Suez Canal can be run on solar energy. This is just for information for you, because it is not that, but Egypt does not have that much of technological base, so India is giving the support. Now, the integration with industries is happening in all these places, which I told you some time back, where electrolysis plants have been set up. I told you 35 plus 3, 38, and total is 38, but that's only a small step. We require 11,000 megawatts of electrolysis plant for 1 million ton. For 1 million ton of gas to be produced, 11,000 megawatts of electrolysis plants required. That means they should be drawing that much of power from the grid or solar farms or green grid to run and produce the hydrogen we want. And if you want 5 million ton, 55,000 megawatts is required. Now, this is not going to be achieved by 2030, even though the hydrogen mission is very optimistic, but I have my own doubts whether they will reach there, because electrolysis plants are still not made. They're only made as sample, and initial kits have come out. So urgent product PLI scheme is not yet to kickstart. So this is going to be a problem area for us. And this is going to be the weakest link in the mission. It's not solar power. We already gone to 150 gigawatts of solar power in India. So solar power is behind us. We can generate. But electrolysis plant, which will produce hydrogen, that needs to get ready. Thousands of them. And we have made only some small numbers of about 15, 16 of them so far. Meanwhile, Leyland's and Tata's both have made trucks which will run on green hydrogen. They have been successful in doing it. So what the government has done, they have identified 10 sections of highways, both in the west as well as in the east, eastern corridor and western corridor, where lots of industries are there in Maharashtra, Gujarat, Andhra Pradesh, Orissa, Tamil Nadu, and I think one portion Kerala is also there, where they have identified those highways as green highways for green hydrogen trucks. Why do you have to identify? Because along these highways, you require, like petrol pumps, you require green hydrogen bunkers so that these trucks can take fuel from there. So the trucks are getting ready. Truck sample initial run is already completed. And now the production has to start on Leyland's and Tata's of trucks. And along the route which has been identified, they will run only on that route, because that's the only place where they will get the fuel, hydrogen fuel, which has been identified by the government. In addition, the government has made this train, the first hydrogen train. It's ready by August, middle of August 25. It has got a 12,000 horsepower train. This will run between Jind and Sonipat section of Northern Railway. Speed is given there. And this is going to do the trial run very soon. The date was sometime in December, but I'm not sure whether the date will be still met. But it is out of the factory which has made this hydrogen train. Now the train has to go do some trial runs and it will start doing this particular section very soon. So in transportation side, trucks and trains will happen from 2026 onwards. But I don't think cars will come. Even though theoretically it is possible to run cars on hydrogen, I think car running on hydrogen fuel is not there, as per me, for next 5 years. It's not going to happen. Some one or two cars may run here and there for demonstration, but it will not be available of the car manufacturing plants available to the public. Definitely not before 2035. After that, you may find some models may come out. It has got advantages, but at the moment, the focus is on electric cars, EVs, which is also going to reduce pollution. So that's a good thing. But hydrogen cars are not going to be there soon. Right. Now, the major thrust for the government is shown in this particular slide. Replace CO2, reduce CO2 with H2. That is the thrust. So that carbon dioxide emission is reduced, pollution is reduced, global warming is proportionately reduced based on India's contribution. And India is required to contribute. It's a global commitment for us. So by 2030, we're supposed to achieve some scales. There are 5 targets. That's a separate topic. I will not get into it. But in that, 1 or 2 things we already achieved, like solar power and intensity of carbon emission, etc. But afforestation targets and the reduction of coal burning, we have not achieved so far and unlikely to be achieved also. We'll discuss that on a separate topic closer to another year later and see where it goes. But let's say what the government is doing about it. What the government is saying is cost of renewable energy has to be reduced. One step, because land is required for solar farm. You require 55,000 gigawatts of power to produce 5 million tons of green hydrogen. So lots of land is required. You have seen a lot of solar farms are coming up in the Kutch area, in Gujarat area, etc., Maharashtra, Andhra Pradesh. So you have to reduce the land cost. So government has got into some schemes by which, with state governments, by which land is given at a lower price, maybe on lease, and also some subsidies given for solar farms, so that solar energy is generated and separate grid is run with solar energy called green grid, so that electrolysis plants can take power from the green grid. Present cost in India is $6 for 1 kilo of hydrogen. I should tell you, if you've got a car which runs on hydrogen and you want to run 100 kilometers in that car, you require 1 kg of hydrogen. That means if you've got a car with you which is running on hydrogen and you're going to buy green hydrogen, it's not available for you to buy. But if you're going to buy it, you will spend $6. $6 is roughly 600 rupees, maybe slightly less. It will cost you 600 rupees to go 100 kilometers, which is much more than which is comparable, I should say. That means your car, if it is giving 16 kilometers per liter, 1 liter is 100 rupees. In Kerala, it is more. In Tamil Nadu, it is less. So 6 liters of petrol will be 600 rupees. You can buy 1 kg of hydrogen and run it. So hydrogen is comparable to petrol as it stands today. 1 kg will give you 100 kilometers. But if you can bring down the cost of hydrogen, out of which renewable energy is an important aspect, electrolysis plant is an important aspect. If you can bring down, then it will be cheaper to run car on hydrogen than on petrol. But You have to set up hydrogen bunkers all over the place for cars to run. So there are some infrastructure costs to be done. So at the moment, as I told you, $6 means as good as 6 liters of petrol. 100 kilometers, the car will run 1 kg. In Australia, it is much less. It's only $3.6 per kilo. India wants to make it at $1 per kilo by 2030, but that's not going to happen. Definitely, because you require scale of production of hydrogen to be very high, and to get into 1 kg, $1 per kg, a lot of solar farms that we set up. So as per some calculation, by 2030, India will be around $3 per kilo. That means roughly for going 100 kilometers in your car, you can manage with 300 rupees of fuel, as against petrol requiring 600 rupees by 2030. But this $3 rate can happen only if you produce around 3 million tons of green hydrogen. That means lots of electrolysis plants, a lot of solar farms, all this is required. And government is prepared to subsidize all this because that's the only way you can meet your global commitment of reducing CO2 emission. So we are planning 3.5 million tons by 2030. Initially, we planned 5, but I think it is coming down to 3.5 now. Government has not announced this change. Many other people are saying it will be only 3, and mostly it will be used by refineries, which is burning coal, fertilizer plants around 0.9, and steel. Steel is not being so enthusiastic about going to producing with green hydrogen, because a lot of consumption of steel takes place within India. It's okay. But if you want to export steel, which we are doing now presently, you will get a higher rate if it is using green hydrogen, and it's called green steel. So if you want to have higher business in steel and exports, then you have to produce green steel. I think Jindal's JSW's plant in Orissa is trying to be maybe the first plant which will produce green steel in India. But as it stands, refineries will take 2 million tons, fertilizer about 1, and steel plant much less. So let me come to the conclusions of today's techno-economic talk. We are talking about green hydrogen mission. And the first conclusion is we have initiated projects on the engineering side, electrolysis plant, safety standards. As I told you, hydrogen needs to be handled with care. It's highly inflammable. So the safety standards required are different. R&D is required in storage, to pressurizing compressors, containers which can take hydrogen. If you want to export it, it has to be in huge drums which can take very high pressure. And some renewable energy projects are also being started. It's a good effort which the government has done. And I think we already kick-started this activity. 8 companies have been identified for making electrolysis plants. Good start. We have made only 38 megawatt. And as I told you, 8 firms, but they have to produce thousands of electrolysis plants, which will at least utilize about 33 megawatts of power, 33,000 megawatts of power to produce 3 million tons. Now that is going to be difficult, and a lot of efforts are required to achieve that. Now, the third conclusion, which is emerging from the challenges, you can't have the EP here and the steel factory 10 kilometers away. You require 10 kilometers of pipe. So put the EP near to the steel plant, preferably inside the steel plant premises, so that he closes down the coal burning and takes green steel the EP, which is located nearby. Now, if you want the EP to be given for trucks and piped gas, obviously you'll require bunks required to be set up along that highways identified. You want in a city a distribution to be done in some particular city, then you require to lay pipelines. Like many cities have got natural gas being distributed. Um, Bombay has definitely got a huge portion. I think Cochin is also going to get it, and maybe a few other cities as well. So this is going to pick up. But if you want to mix green hydrogen with natural gas, I think it's about 5% is trials have been completed, mixing. Maybe it'll go to 10% or 15%. Once you do it, hydrogen can be used, the energy can be used for burning the kitchen burners in the house. Then the solar farm is also required to be near the industry, because preferably, because the EP is going to be near the industry. The power required for EP has to come from solar plant. So if it is kilometers away, then you have to run overhead grid line, cables, etc. To minimize that, if you can get. So land is a huge commodity, is a very important commodity required in large areas are required to go to green hydrogen. Now, that is a challenge which some states will find difficult to give land for all this, electrolysis plants and solar farms. In some places, it may be easier. Industries, location-wise, this is going to be industry location-specific. But I don't see any major holdup. Solar farms can come from a distance, and power can come from by grids from there. But electrolysis plants need to be located near the industry. Cost of hydrogen we discussed. We want to make $1. It's not going to happen. At best, I think we'll produce $3 per kg by 2030. Even if that happens, I told you, your car will run 100 kilometers.
And the sixth one, you have to explain.
Okay, so I'm restarting now. So the last point is, government wanted to make 5 million tons produced at $1 a kilo by 2030. Now, that is not going to be possible from the way it is going. Some study which has been done, which says that maximum you will make 3 million tons, and it costs about $3 per kilo of hydrogen. But even if it is $3 per kilo, you will be able to run your car 100 kilometers for 300 rupees, which today is about 600 rupees on petrol. So there's benefit. I'm just telling what are the customers. Otherwise, the customer should find that the the fuel available for transports are cheaper. The fuel available for power generation is cheaper. Cooking gas is going to be cheaper because it's going to be mixed with natural gas, and heat content is going to be much higher. And most importantly, the pollution will be less. And global warming, India would have done its contribution to reducing global warming. With this, I come to the end of this talk. Thank you, ladies and gentlemen. Jai Hind. Okay, I'm stopping the sharing.
Okay, sir. Thank you. Thank you very much. പ്രധാനമായിട്ടും സേഫ്റ്റി സ്റ്റാൻഡേർഡ്സ്, അതുപോലെ തന്നെ മോർ ഇലക്ട്രോളിസിസ് പ്ലാന്റിന്റെ ആവശ്യകത, അഗെയിൻ ലൊക്കേഷൻ ഓഫ് പ്ലാൻ നിയർ ടു ദി സ്റ്റേഷൻസ് ആൻഡ് കോസ്റ്റ് ഓഫ് പ്രൊഡക്ഷൻ, ഇതെല്ലാം പ്രധാനപ്പെട്ട റോഡ് ബ്ലോക്സ് എന്ന നിലയിൽ അനുമാനിക്കാം. So thank you, sir. Thank you very much. Srikumar, sir.
Yeah. Again, good topic. A series of talks is making of hydrogen. And I'm also used to hear from here and there. 2 days before Dr. Surendran, one of our professor also made a session in Institution of Engineers Hall. Trivandrum. Anyway, it is this hydrogen going to be very bringing a great change in the all over the world. It's going to be a wonder fuel. It will be changing the whole scenario of the present shortage of fuels and other and also enriching reducing the zero carbon emission and all. There are so many advantages of this hydrogen and as well as many uses, as he said, for gas transportation and cooking gas and so many uses. So only what I gather is the carriage of this gas due to its volume and its safety standards to be followed while handling this gas. So that's why he is saying that all this to be located near the plants, electrolysis plants. So that is one of the roadblock about that is what I assume. The carriage of gas and its safety standards. And Kannan, how this gas is going to be exported? It is by
Yeah, good question, Sri. Gas is going to be exported by ships. Today, how is natural gas coming to you? In Trivandrum, how are you getting natural gas? Or Cochin, you're getting natural gas. Natural gas comes as CNG to us, compressed natural gas. Auto rickshaws are running on CNG, cars are running on CNG. There are many taxis which are running on CNG. Has got a cylinder in the dicky, and you can't put your suitcase there. You would have experienced that. So CNG is available today in India. 50% is domestically produced. There are natural gas wells both on the western coast as well as on the eastern coast, as well as some land-based wells are also there. From there, natural gas is extracted and sent by trucks to Trivandrum or Cochin, wherever it is. It comes by trucks. You would have seen the trucks with a huge, it's called a bullet, long cylindrical shaped carrier, which carries natural gas inside under pressure. That natural gas is coming to the petrol pump, and from there it is transferred to another container in the petrol pump, which is underground. And auto rickshaws come and take their natural gas at their pressure, which is required, which is much lower. So transportation of natural gas is under pressurized containers by land. It can go by sea also, right?
Yeah.
For sea, it can be even higher. Higher pressures can be taken because the size of container can be much bigger than what a truck can carry. So big volumes can be sent by sea by having huge containers which have got these cylindrical or spherical structures into which gas is pressurized and sent. Same thing will happen in hydrogen. Hydrogen also being a gas will get pressurized and sent. Only thing is hydrogen is voluminous. So it requires an even higher pressure to bring it to the size of the container which is taking natural gas, which is a heavier gas. So hydrogen gas will also get exported by ships in huge pressurized containers. Now, how does this happen? When a ship comes to the jetty, let us say Cochin has got a natural gas, it's a terminal in Cochin. There's a natural gas terminal in Cochin where a ship comes with natural gas from abroad. Let's say the ship has come from Qatar. Qatar is one of our exporters to India for natural gas. It comes there, and that ship's natural gas containers are connected to some other containers on the jetty. And that is gas is transferred to those, and from there, the pressure is reduced and transferred to other containers which are also on the jetty. This is called degasification. High pressure of which is the ship is brought to a medium pressure on the jetty. And from there, trucks take it at the medium pressure to petrol pumps. Petrol pumps store their natural gas under medium pressure underground and supply natural gas or CNG to auto rickshaws and cars at a lower pressure. So the pressure is first dropped from ship to jetty, then by trucks, then it is brought to petrol pump where it is dropped further. Same thing happened with hydrogen, but they have to have different networks of distribution and supply. It's only in case of domestic gas, which is planned, you will have natural gas mixed with 5% hydrogen so that the flame will be having a higher value of energy. That means cooking will be faster if you mix hydrogen. Those trials have been completed, and it's not yet started in India, but it is planned to be started. Similarly, natural gas is mixed with hydrogen to run power plants where natural gas is the fuel, so that energy content is higher. Have I told you the mechanism?
Yeah, thank you.
Yeah.
Uh,
Any other question?
സാർ ഒരു സംശയം ഇപ്പം നമ്മൾ ഗ്രീൻ ഹൈഡ്രജൻ ഫ്യൂലായിട്ട് വരുമ്പം ഈ EV ചാർജിങ് സ്റ്റേഷൻ അങ്ങനെയുള്ള അല്ലെങ്കിൽ EV വെഹിക്കിൾസിന്റെ പ്രോബ്ലം ഉണ്ടാവും, അത് കുറയുമോ?
No, EV is another way of running your car on battery, which has got a different type of life and different type of recharging requirement and replacement requirement, etc. Cars running on green hydrogen are half EV. Cars running on hydrogen are half EV. Why did we say it's half EV? Hydrogen is taken in a small cylinder inside the car, and oxygen is taken from atmosphere as the car moves, or there's a blower which will suck oxygen. Both hydrogen and oxygen are combined in a unit called fuel cell, where oxygen and hydrogen combine. It's an electrochemical unit where oxygen and hydrogen combine, and when they combine, they release a lot of energy. That energy is used, and the second product is H2O, which goes out of the car exhaust as water or steam. Now, that energy which is released in the fuel cell is electrical energy. Initially, this chemical energy, it becomes electrical energy and charges your battery. And thereafter, the car is EV. So now you understood, hydrogen car is half EV.
പക്ഷേ ഇങ്ങനത്തെ ചാർജിങ് സ്റ്റേഷന്റെ ആവശ്യമില്ല, അപ്പം പുള്ളി ഹൈഡ്രജൻ ഇസ് നീഡഡ്.
ഇല്ല, ചാർജിങ് സ്റ്റേഷന്റെ ആവശ്യമില്ല.
യെസ്.
No, I don't know whether hydrogen car will come with such a way, saying hydrogen the tap close ചെയ്തിട്ട് battery direct ആയിട്ട് ചാർജ് ചെയ്ത് വണ്ടി ഓടിക്കാൻ പറ്റുമോ എന്ന് ചോദിച്ചാൽ എനിക്ക് അറിഞ്ഞൂടാ. Because I haven't seen a hydrogen car yet.
Like hybrid.
I don't know whether that is going to come or not. I don't know whether it exists or not. I haven't seen a hydrogen car, but I've seen photographs. But it's a good question which you asked. But I think it should be possible. I should close the hydrogen, keep the fuel cell off, and charge the battery directly and run the car. Hybrid ho gaya.
Yes, hybrid.
Okay, thank you.
കാരണം ഇന്നൊരു ചോദ്യം ചോദിച്ചിരുന്നു, ഒരാൾ ചോദിച്ചിരുന്നു, അതായത് ഒരു EV സ്റ്റേഷൻ സ്റ്റാർട്ട് ചെയ്യാൻ പോവാണ്. അപ്പം ഞാൻ ഇന്ന് ഹൈഡ്രജൻ ഫ്യൂവലിനെ കുറിച്ച് പറഞ്ഞു. അപ്പോൾ ചോദിച്ച ഒരു ചോദ്യം ഇങ്ങനെയാണ്, കാരണം ഹൈഡ്രജൻ ഫ്യൂവൽസ് വന്നു കഴിഞ്ഞാൽ ഇപ്പോൾ ഒരു 5 years 2030 ആകുമ്പോഴത്തേക്കും ഒരുമാതിരി വരാമെന്ന് വിചാരിക്കാം അല്ലേ? 2030
Hydrogen,
ഹൈഡ്രജൻ
hydrogen for car.
ഫ്യൂൽ.
Hydrogen as a fuel for car, in my estimate, not before 2035. For 10 years, you won't have it.
Yes.
For 10 years, it is petrol, diesel, and EV only,
Gas,
not hydrogen.
gas also.
But hydrogen will go for trucks. Yeah, Adi.
Well, gas also. Gas ഉണ്ടല്ലോ.
Gas ഇപ്പോൾ ഓടുന്നുണ്ടല്ലോ.
അതാ പറഞ്ഞേ.
So many petrol, diesel, natural gas. Now hydrogen also will come.
Okay. So വേറെ any questions ആർക്കെങ്കിലും?
I'll ask physics expert Hari.
ഞാൻ ഇലക്ട്രോണിക്സ് പഠിച്ചത്, ഗ്യാസ് അല്ലേ പഠിച്ചത്.
ഇപ്പൊ അതൊക്കെ നിർത്തി, സൈക്കോളജി മാത്രമേ.
No, it is going to be a game changer, but
Yes,
the hurdles are many. And it's a good point which you
I was
said.
about to say, of course, Kanna, you give a very informative talk, no doubt. It's a very dream project. When you see the hurdles before you, it's a very dream project. ഈ 2030 ഒക്കെ അത്ര പെട്ടെന്ന് വരാൻ സാധ്യതയൊന്നുമില്ല. കാരണം
Harry, we have no option.
And what I'm telling is that you have to necessarily do it. You want to survive, you do it. But once you realize it, because as you have even mentioned, you can even export fuel or emperor. The game.
See, why
a real game change. We become we don't depend on the fossils. I mean, oil and other thing. നമ്മുടെ എക്കോണമിനെ ഒരുപാട് ബെനിഫിറ്റ് കൊണ്ടുവരുമോ?
Huge effect on economy because you'll be reducing your oil import.
പക്ഷെ ആൾക്കാർ സമ്മതിക്കുമോ എന്നാണ് നോക്കേണ്ടത്.
ഏത് ആൾക്കാര്?
നമ്മുടെ ട്രംപ് കൂട്ടുകാരെ കൊണ്ടല്ലേ ഇതൊക്കെ നമ്മളെ അവരെയും കൂടെ എന്തെങ്കിലും ബ്ലോക്ക്
ജെൻസി.
ട്രംപ്
ജെൻസി തന്നെ ഉണ്ടല്ലോ അവർക്ക്.
ഇതില് why we have a huge export potential? I've told you we got a huge solar energy potential, and that is one of the reasons why we'll be able. And if you want to export, it can be only by ship. It cannot be by aircraft. It cannot be by land. How much will you? So if you want to export economically, it has to be by sea. And India has got such vast coastline. You can have what is called different hubs created, where I think Tuticorin is going to be one of the hubs for green hydrogen.
Because it has got because thanks to Vizhinjam, we are all stands to gain.
Yeah, because that the important requirement when Sri Kumar asked how will you export it, the electrolysis plant has to be on the coastline. The solar farm also has to be there. So solar farm, electrolysis plant, and hydrogen storage. All this will have to come in a huge piece of land, very close to coast. So all you'll do is when the ship comes, you have to only send the hydrogen to the ship in a pressurized pipeline. And that's going to happen.
Land,
Kerala has got a problem. You won't get this land in Kerala, but Tamil Nadu has got a lot of land, which is towards the coastline. Gujarat has got a lot of land. Orissa has got a lot of land, which have got coast. Maharashtra, some parts are there. So it is in these areas where you will find hydrogen export. So some ports from west coast will go export to west, and some ports which are on the east coast will export to Japan, Korea, etc. They can't produce green hydrogen. People are buying oil from Middle East.
Where does China stand in this?
Interesting. China has been able to get a large amount of solar energy. China has got a huge amount of land, but doesn't have as much solar energy as India has. They are far away from equator. They don't get average more than 6 hours, 7 hours, 6 hours of solar energy in a day. while we get up to almost 10 hours. So they are overcoming that aspect by having more land, more solar fields, etc. Electrolysis and power level. And he has got enough capability of enough coastline to start exporting. But I don't think the export market, we are in a better position geographically. From the middle of Indian Ocean, we can reach to the east and west easily and supply the new oil. The old oil is not in demand after 15, 20 years. It's only a new oil. കുറച്ചുപേരൊക്കെ നമ്മൾ കാണും ഈ ഹൈഡ്രജന് എക്സ്പോർട്ട് ചെയ്യുന്നത്. സാബു ഓർക്കണേ കാണുമ്പോ.
കാരണം ഇത് സ്പേസിൽ നമ്മൾ ഉപയോഗിക്കാറില്ലേ?
സ്പേസിലോ?
സ്പേസ്
Aeroplane.
That's a very interesting
space,
one.
I mean.
Spacecraft requires fuel only for the rocket to reach orbit. Once you're in orbit, you don't require fuel at all. You would survive on solar power, which is required for the equipment. Propulsion power venda. Avada orikku speed etikകഴിഞ്ഞാ avada is a vacuum. He'll keep going round and round and round at whatever speed you have left him there. You don't require any further engine to run. In fact, when you want to bring him back, you have to reduce the speed and you have to decelerate. You have to make sure it doesn't get burned out when it enters the atmosphere. Okay, so earlier hydrogen was used as a rocket fuel, right? But there are difficulties in controlling the amount of burning in hydrogen. See, one of the important things in rocket, when the rocket is launched from Sriharikota or any other rocket station, till it goes up and reaches the orbit, the speed has to be controlled of the rocket. And that speed can be controlled only if you control the burning of the rocket. The burning of the rocket. Initially, it was liquid fuel. And the liquid fuel valve used to open more or less to make sure the burning. Then slowly, spacecrafts shifted from liquid fuel to solid fuel. And the solid fuel is shaped in such a way. It is geometrical shape is in such a way inside the cylindrical casing that as it burns, the area is uniform. It is very difficult to imagine for a rocket which you fire from a firecracker when you launch, the burning is not uniform. It burns with great speed and then after some time it fizzles out. It is not uniform. They don't control the amount of gas, the powder which goes in for burning. It just gets lit and one uncontrolled burning takes place. Or very little control is there. But in rocket, you control the speed by the burning of the solid fuel. Then only you have control over the speed, which is very important for stability. But once you reach the orbit, then the satellite is disconnected and the other thing falls somewhere. The satellite is on its own speed. Okay. Sabu.
It's a nice lesson.
Sabu, sorry for this interruption in between last minute. Okay. Right.
Okay, sir. Thank you.
Thank you.
Thank you very much.
Bye-bye. Good night. I'm leaving. Good night, Sri. Good night, Hari. Bye.
Good night. Good night, Kannan. Good night, Sabu.
Good night, sir.
Everybody.
Bye. See you.